everybody. Today I'm gonna show you how to solve a problem using three-way ANOVA. Fatigue in metals has been defined as simultaneous action of cyclic stress and chemical attack on a metal structure. In the study effect humidity of several surface coatings on the fatigue life of 2024-T351 aluminum alloy conducted by the Department of Mechanical Engineering at the Virginia Polytechnic Institute and State University, a technique involving the application of a protective chromate coating was used to minimize corrosion fatigue damage. Three factors were used in the investigation, with 5 replicates for each treatment combination: coating at 2 levels, and humidity and shear stress, both with 3 levels. The fatigue data recorded in thousands of cycles to failure are as follows. Question A. Perform an analysis of variance with the level of significance equals to 0.01 to test for significant main and interaction effects. For question B, make a recommendation for combinations of the 3 factors that would result in low fatigue damage. Your A would be the coating, uncoated aluminum and chromated aluminum. And your B would be the humidity, low, medium, high. And your C would be the shear stress per psi, 13,000, 17,000, and 20,000. Since there are 3 factors to consider in a three-way ANOVA, we need to develop 7 different null hypotheses for all factors and their interactions. For the first null hypothesis, all means under coating are equal. For the second null hypothesis, all means under humidity are equal. For the third null hypothesis, all means under shear stress are equal. For the fourth null hypothesis, the means under coating and humidity have no interaction. For the fifth null hypothesis, the means under shear stress and coating have no interaction. For the sixth hypothesis, the means under humidity and shear stress have no interaction. For the last hypothesis, all means under coating, humidity, and shear stress have no interaction. After formulating the null hypothesis, we have to write an alternative hypothesis that will oppose the null hypothesis. For the first one, we could write the first alternative: at least 2 of the means under coating are not equal. The second alternative: at least 2 of the means under humidity are not equal. For the third alternative: at least 2 of the means under shear stress are not equal. For the fourth alternative, the means under coating and humidity have interaction. The fifth alternative, the means under coating and shear stress have interaction. The sixth alternative, the means under humidity and shear stress have interaction. For the last alternative, all means under humidity, coating, and shear stress have no interaction. Now, after formulating the hypothesis, now we have to find the critical region. For we have a level of significance equal to 0.01. Now, we have an A equal to 2, a B equal to 3, a C equal to 3, and an N equal to 5. For the first, it will equal to, for V1, we have A minus 1, and for V2, we have A, B, C, N minus 1, equals to 7. For the second, we have a B minus 1 for V1 and ABC N minus 1 for V2, which is equal to 4.91. Now doing it for all the rest, which is given at the table, you will obtain all these values. Now, after getting all our critical region, we will list our sources of variation. We have 7 sources of variation: SSA, SSB, SSC, SSAB, SSAC, SSBC, and our SS error. The equation for each sources of variation will be pointed out below, so please stay tuned. As you can see, for each equation, there is yi dot dot dot, y dot j dot dot, y dot dot k dot, yij dot dot, y dot jk dot, yi dot k dot. They are all the summation for each column, row, and other sources. For the degrees of freedom, we have A equals to A minus 1, B equal to B minus 1, C equal to C minus 1, AB equal to A minus 1 times B minus 1, AC equal to A minus 1 times C minus 1, BC equal to B minus 1 times C minus 1, ABC equal to A minus 1 times B minus 1 times C minus 1, and error equal to ABC times N minus 1, and the total for times 2 ABCN. For the mean squares, we have 7 sources, 8 sources of mean squares, and it will be pointed out below, so please stay tuned. To get the F naught, we divide the mean square of your sources of variation to the mean square of the error. So computing it, you will get values such as 0.046, 2.13, 45.96, 3.41, 0.075, 3.15, and lastly 1.93. Now let's solve for the first source of variation, SSA. Note that yi dot 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 squared can be obtained by summating all the variables, which will result to the final answer. Now, summating each box, you will get, for the first one, 40,637. For the second box, 40,517. For the third box, 47,466. Doing the math by adding them all, you'll get the first yi, 128,620. Now, applying the same method in the second A, you will get the answer 133,033. Adding both yi, you will get the final answer 261,653. Now let's solve for the second source of variation, SSB. Y dot J dot dot can be obtained by summating each column like this one. 40,637 plus 34,802. You will get 75,439. Then applying the same method, you will get 100,000, 7,039. And the last word is 79,175. Now, doing the math, you will arrive to this answer. 19,876,891. Now let's solve for the third source of variation. Y dot dot K dot can be obtained by the following. Now add the 30 and add all the values under 13,000. Then you should arrive at the answer 176,380. Now do the same under 17,000. Adding all of them, you should arrive at the answer 64,025. Doing it again for the third time under values of 20,000, you should arrive at the answer 21,248. By adding all the get values of 176, 380 up to 21,248, you will arrive at a grand total of 261,653. Now, in putting it in your calculator by doing the math, you will arrive at the answer 427,993,946.4. Now, so for AB, we should get the Yij dot dot by getting the values for each summation of each box. Now, getting all the summation in each box, square all each values by each summation in each box, then adding them all, minusing it to the sources of A minus B minus the grand total. And you will arrive at the 31,736,625.9. Now for source BC, we have to get the value of y dot jk dot, and it can be obtained by the following procedure. By summing all these same rows like this one pointed below, then you should get the same answer as such as 43,704, 23,856, and 7,879. Now, doing the same thing, applying the same math, you will arrive at these answers. Then, to get the values, get the square of each answer computed, then minus it to the sources of SSB minus SSC minus the grand total, then you'll arrive to this answer. Now let's solve for source AC. We'll need yi dot k dots. To obtain yi dot k dot, To get SSAC, we'll get the value of yi dot k dot. By doing it, you will get the summation of each n 5, like adding 4,580 up to 3,549. Then applying it to the same procedure, you'll get the answer showed below. Now, let's solve source AC. To get source AC, you need to get the value of yi dot k dot. By obtaining the value of yi dot k dot, sum the values under 13,000 of A1 up to source A2 under values of 20,000. Then squaring all of it. After getting all the sum, minus it to source AC, A sources A minus sources E, minus it to the grand total squared divided by ABCN. Now lastly, let's solve for ABC. To get yijk dot, sum all the values that is pointed out below, as in summing it, then square all of it, then minus it to the sources A minus sources B minus sources C minus to the grand total squared divided by ABCN. Now, doing the math, you should arrive at this value, 36,034,808.8. Now, let's solve for the total. Square all the values, as in all the values that is being pointed out below, then being elaborated, such as squaring 44,580 up to 751 squared, then minusing it to the grand total, you will get the values. You should arrive at the value 910,395,313.1. For the total error, minus the values obtained at A up to source ABC to the total treatment. Then you should arrive at this answer. We'll obtain the degrees of freedom. By using the chart again, A will equal to A minus 1, B equal to B minus 1, C equal to C minus 1, then AB will equal to A minus 1 times B minus 1, AC equal to open close quantity A minus 1 times C minus 1, BC equal to B minus 1 times C minus 1, ABC equal to A minus 1 times B minus 1 times C minus 1, error will equal to ABC times n minus 1, and the total will equal to ABCN minus 1. Now let's get the mean squares. For A equation, the following equation is divided by its degrees of freedom. You'll get the answer 216,384.1. And applying the equation at for the following, you'll get the listed answers below. Now, to compute F, you need to divide each mean square by the mean square error. So, applying, for example, 216,384.1 divided by 4,655,738, you'll get 0.046. Then, do the math, you'll get the answer below. Now, the critical value was obtained. Now, let's check our null hypothesis if it's rejected or not rejected. Now, after getting the computed F, let's compare them to its respective critical regions. As you can see, the only rejected null hypothesis is the third one because its result is greater than its critical region. 45.96 is greater than 4.91. It means that all means, at least two of the means under shear stress, are not equal. We would recommend that the combinations of the three factors are uncoated aluminum under medium humidity at 20,000 shear stress.